Greetings, this is Jim Lindsay. This is a CIS 141 lesson, and this one specifically is over Chapter 5 from your textbook. We're going to be learning about system software in this chapter and throughout this lecture. So, welcome. System software is part of a broader category, which is basically software. And so, when you start to learn about software, as we're going to cover in just a minute, there are different types of software, especially in an academic environment. We really tend to categorize things to make them easier to remember and to learn about. So let's first just cover what software is in general, and then we're going to get to specifically what system software is. So software is the component of the computing system that you can't touch. It's not tangible. Think about a mouse or a keyboard or a monitor or a system unit. Anything you can physically touch and pick up or move, that's hardware. The stuff that you would buy the computer, to get to, that's software. For example, you may want productivity software like Microsoft Office because you may need to make spreadsheets to keep your budget, or you may need Microsoft Outlook to send email, or you may want Microsoft Word so you can type affidavits or memos or any contracts or any sorts of other documents you might want to produce. Those are all examples of software. Those are the basics. What is hardware? What is software? I think it's really easy to forget that software is created by people. And pictured in front of you on the slide, you have a picture of a very young Bill Gates from Microsoft. The people that write the lines of instructions or the code for software are called programmers. That's their job title. And so Bill Gates, that's somebody that you probably recognize. He's a very famous programmer. Here's a little screenshot of what some code would look like. This is PHP code, and this is just PHP is a scripting language that you can use to do all sorts of things. It's usually tied in with HTML, but specifically what this one does, this sends a message. When you submit, when you fill out an email, or when you fill out a form on a web page, when you hit the submit button, your data is passed over to this script, and then the script sends that data to somebody, in this case Amy Manning at topper.wku.edu. And so this is just a little bit of code that you can take a look at. And this specifically, again, is PHP, which is just one of numerous languages that you can use to write software. All right, next what I want to cover with you I want to help you differentiate between application software and system software, because we're going to spend this whole lesson learning about system software. Look at the graphic on the screen in front of you, if you would. You have three concentric circles or three concentric ovals, and in the very center, the red oval that you see there has an H in it that's supposed to represent hardware. So at the very center of this system is hardware, and then surrounding all of the hardware is system software, and then beyond that you have application software and you have users. You and I are the users of the system, and so you and I, as well as application software, are on this outermost blue oval, and between us and the hardware is system software. System software is software that interacts directly with hardware. It's the only type of software that does that, and that's going to be helpful to you as you try and learn about these different types of software. If you're trying to differentiate between application or system software, well, does it directly interact with the hardware? If the answer is yes, then you're talking about system software. Your textbook talks about operating systems and utilities as the best examples of system software. I agree that those are two great examples, but in addition to that, I would also add device drivers, and we'll learn about device drivers to some degree as we go through this lesson. So as you're trying to figure all this out, three things that you can try and remember as examples of system software would be operating systems, utilities, and device drivers. Just to give you a little bit more information to explain this graphic, Think about this. Let's say you wanted to change the picture on the desktop of your monitor, and I'll meet you at my desktop to demonstrate this. Okay, I'm on the desktop of my computer, and I'm using a Windows 8.1 computer, so you might have a different look to yours, of different options, and what you'll see in just a moment. But if you're using a Windows computer, the basic steps are going to be the same. If you're using Apple, I don't know how you do it on an Apple. But the fundamental steps of what Windows is doing, what I'm about to show you with what Windows is doing, the Mac OS X or OS 10 operating system on your Apple does the same thing that the Windows operating system does in this example. I think I have Mavericks on my iMac, and I have like as the background picture on my iMac, I have like the big picture of the wave rolling. You're doing the same thing through OS X or OS 10 as what you're about to see in Windows here. Let's say I wanted to change this personalize the screen, so instead of being a flower here, that it was something different. Well, how would you do that? Well, it's real easy. From the desktop, you can just simply right click and then come down here to where it says personalize, and from there are these different themes that you can choose. We'll go with Windows here, and that looks great. Let's go with that one right there, and we'll go with like the hot air balloon. So if I select that and save changes, then what I see on my monitor is now this pretty picture of a hot air balloon instead of the flowers that were there a moment ago. I could change the resolution that my monitor is displaying information at. I could go into here, go into screen resolution, and change that. In order to make these changes to how this hardware is functioning, I'm having to go through the system software. That's what I'm trying to communicate through this example. I'm having to use the Windows operating system to do that. And whether that's Windows 8.1 or Windows 7 or Windows 98 or Mac OS 10 or Linux, you're doing the same thing. System software interacts directly with that hardware. So let me get back to the PowerPoint, and I'll meet you back there in just a moment. Okay, and I'm back in my PowerPoint presentation. If you look in your textbook, they give a really good example of users interacting with the hardware, and I'm trying to find the page number here. It's on about page 178 in your textbook, and it talks about the 6 steps that you would go through, basically, or that would happen in the background if you're just trying to print a document. You've just typed a really good research paper, or you've written a very good memo. You want to print that. Well, in order to get from you to the hardware, what's going to happen is you have to Microsoft Word, the application software that you're using, has to turn that document over to the Windows operating system, which in turn interacts directly with that printer, and then when the job is done, the system software can then give confirmation back to the application software, which can then talk to you. And so application software and users have to go through this system software. That's the point we're really trying to make here. But on that page 178, if you want to look at those 6 steps that are pictured in that graphic, that's a very good example of this also happening. So that's the difference between application and system software. Okay, so now that you know the difference between application and system software, we're going to spend the remainder of this lesson learning about system software, and where we'll spend a good portion of time is basically right here. What are the functions of that operating system? Because your operating system is a wonderful example of system software. It includes utilities. It includes device drivers. And so we can talk about operating systems, and by talking about operating systems and their functions, we can cover basically all the kind of stuff that goes into system software. So this is where we're going to spend quite a good deal amount of time. Okay, I'm not going to tell you every single thing about every single one of these functions, because you can read, and the book does a good job of explaining these things, but I do want to point out some of the most important facets of some of these different functions. So first of all, interfacing with users. Back when we were in Chapter 4, you guys learned about the mouse and the pointing devices, and you learned about the graphical user interface. You learned about its story, basically, of how Xerox, that's the Xerox company thought up the graphical user interface, but it was Apple who actually commercially implemented it successfully first, and then everybody else did after they did. But that facet where basically the user can input data and get output, can interact with the system, that's one of the jobs of the operating system. And so whether you're using a graphical user interface or the command line interface, and you also learned about it, was the predecessor to the GUI back in Chapter 4, that's one of the jobs that the operating system has to take care of. One of the newest interfaces that's out is basically your touch devices and your voice input devices. Those are taking off like wildfire, and so any kind of gesture recognition, even if it's from a distance, if we're talking about like game controllers where it recognizes your body positioning, or even just hand gestures that you make, those are all forms of interfacing, of inputting with data into a system, or even outputting. So that's one of the jobs of the operating system. The next thing it goes into, it talks about booting the computer, and that's when you turn it on. And basically when you hit the on button, what happens with the machine, and it describes that in the book for you. It talks about the post test and all that sort of stuff, and one of the things I want to point out to you is there's something in here it refers to as the kernel, and it's kernel, like a kernel of corn, KERNEL, and that is when a machine is turned on, the kernel, or basically the heart of the operating system, is pulled from the hard drive and loaded into memory, and then from there everything else starts to take place. And the reason I want to bring that up is because you may have heard of an operating system called Linux, and if you haven't before, then you'll certainly hear about it in a little bit of detail just later in this lesson. But Linux was developed by a guy named Linus Torvalds, and he was a student in college when he thought this stuff up, and he was about your age. He's like a 21-year-old guy, and he looked at the Unix operating system, that's UNIX, and he said, I would like to make my own operating system. I'm going to use Unix as my starting point. And he modified that, and he basically wrote the kernel for a new operating system called Linux, LINUX. And from there he put that kernel, he put all the code for it on the internet, or available through the internet on a web page, and other people started to use it and contribute to it and write additions for it. And that Linux operating system has grown and grown and grown in popularity, and now it's used a lot. It's a very popular server platform, or server operating system, especially for web servers. And so when you learn about Linus Torvalds, when you learn about the Linux operating system, I just want you to take away that a guy that's your age looked at a well-established operating system, the Unix operating system, and pulled out the parts he thought would be needed for a kernel, for the heart of an operating system, and wrote that differently and for himself, and that became Linux. One of the ways you can remember that is basically, think about if you planted a kernel of corn in the ground and you watered it and you nurtured it, you basically put fertilizer and all that sort of stuff on it. Eventually you're going to get a stalk of corn from that kernel, right? And so your operating system, through the booting process, once that kernel gets loaded into RAM, and all the different checks and system checks are performed, then from there the other data that's needed to run all the parts can be loaded. So I wanted to point that out to you. All right, the next function, configuring devices, is where your textbook mentions device drivers, which I kind of consider its own little category of system software. Device drivers are little programs written by hardware manufacturers which tell a computer system how to use the device. For example, let's say you bought a brand new external hard drive. When you plug that thing in through the USB cable, there's going to be some through plug and play. That's basically where you can plug something in and it's recognized and you can use it. That's what plug and play is. Through that plug and play process, your computer's operating system is going to see, oh, here's a new thing, here's a new piece of hardware. Here are the instructions that are compatible with us, for this particular, for Windows 8.1 or Windows 7 or OS 10, and it loads those instructions so the system can then store data on that external hard drive or get data from it. And so that's what a device driver is. And think about how difficult that would be if you were a hardware manufacturer. On top of just coming up with a new piece of hardware, once you've done that, then you have to write different instructions for that thing to work with all those different versions of operating systems. It's pretty daunting. Operating system companies have made that a little bit easier through something called APIs, and we'll talk about those in just a second. But those application program interfaces allow people writing code, instead of having to write every single line of code, if there's something that you want to do like print or something that you want to do like display something to the monitor, you can call on a pre-built chunk of code called an API. But as those hardware manufacturers are making those device drivers, so that the operating system can configure those devices to work correctly, they will frequently call on those APIs that are part of the operating system. Our next function is the managing network connections, and I'm sure you've seen this many times, either on your tablet device like an iPad or a Surface, or if you have like a phone and you're trying to join a Wi-Fi network, or if you have a laptop and you're trying to join a Wi-Fi network, or if you have a desktop and you plugged into like the wall in your dorm and you want to have that wired connection. The operating system, be it Windows or Mac OS 10, it's using something called a network interface card, and the acronym for that is NIC, a NIC. And the NIC, it could be wireless, it could be wired, but through that network interface card, you're basically allowing the computer to send data and receive data, either through that wired or wireless connection. And so that's one of the really important jobs of the operating system, especially since so much of what we do now is cloud-based. Think about with all these different cloud storage applications we have, like SkyDrive and Dropbox and Google Drive. If you can't connect to the network or to the internet, then you're kind of doomed, because then your stuff is not accessible, right? Well, that network connection is especially critical for that to work, and so that's one of the really important jobs of your operating system. Okay, our next function is the management and monitoring of resources and jobs, and your operating system is basically working in the background whenever the computer is on, and it's making sure that whatever you type on the keyboard gets input, whatever you click on with your mouse is being input. It's keeping track of whatever programs you have open, and it has to manage all of that, and that's a really big job. You've probably seen the task manager if you've used a Windows computer for any length of time before. The task manager is basically when you hit alternate control delete, and it brings up, I'm going to do that now. I'm going to alternate control delete all at the same time. I'm going to bring up the task manager here, and you'll see this shows you all the different things that are being run on this computer right now. And even though I'm mainly just using PowerPoint and Camtasia to record, what I'm trying to talk to you about, all these other things are going on in the background. So that's a tremendous amount of stuff to keep track of. You can use this interface, this task manager, to stop things. For example, let's say I wanted to get rid of that AAM updates notifier. If I click on that, I can then come down here, click on end task, and make it stop. So this can be a really good troubleshooting tool as well. If your machine is locking up or freezing, and you want to try and figure out, well, what's using up all my memory? You can see, like, by this you can basically rate stuff like what is using the most memory. Well, in this case, Camtasia is using the most memory, 209 megabytes of memory. If you want to see what's consuming the most CPU cycles, you click on this one, it'll rank that. And my desktop manager is using the most, and so on. So if you look in here and you see like some really weird named sort of thing that doesn't look like it's any part of the operating system, maybe you can select that and then end it and see if that keeps your system from locking up. And maybe that's some indicator that you have some sort of malware, like a virus or adware or something running on your system. And so this can be a really useful tool in troubleshooting, and this is available through the operating system. This is again called your task manager. If you look at these other tabs, for example, this will tell you, for example, like these are the different these are the different resources on my computer and how they're being consumed. You'll see like the CPU here. This is how much of my 3.24 gigahertz are being used at a time. With memory, it gives you some sort of idea about. I have 16 gigabytes available for memory. How much am I currently using, and so on. This little dude down here, this Open Resource Monitor. If you're using Windows 7 and you go into this Performance tab, this is what you're more likely to see using Windows 7. If you go to this tab for CPU here, you'll see like there's CPU 0, CPU 1, CPU 2, and these are the different cores of my processor. Basically, I have an octa-core processor, and it starts numbering at 0. So like the 8 different cores each have different jobs, and you can see how hard each one of those is working at one particular time. And so you see like this CPU, basically the second one, it's numbered CPU 1 because computers always start their numbering at 0. But this second one is doing the hardest amount of work here. So these are, again, this resource monitor, the task manager, this is all stuff that comes from your operating system, and they help you monitor your system, they help you manage your system, they help you basically troubleshoot especially if you get things like viruses or malware. You can kind of figure out, especially through this processes tab, if you see really strange stuff in here, you can figure out, oh, I think I've got a problem. So let me go ahead and close that guy out and go back to our presentation. And our next item function on the list here is basically file management. And that's basically what this picture shows you. Your operating system is going to help you create folders and keep stuff organized. Your hard drive has a whole bunch of files on it, and we create directories or folders, things like My Documents or program files or drivers or whatever, and each one of those folders can then contain things like files, and that's helpful for us because as humans, I think we do better when we make containers for our stuff. So for example, with your schoolwork, you may have a folder for summer 2015, and in it you might have CIS 141 and Finance 330, and in each of those folders you'd have like a syllabus and a calendar and homework that you did for each of those respective classes, and store store stuff accordingly. That is the operating system that's making all of that possible. Instead of all the files just being in one place in one giant mess on the hard drive, it allows us to have this file structure, this file management in place that we can use. Our final function is security, and we could talk a really long time about security, and I won't. There's an entire chapter of this book dedicated to security, but mainly what I want you to take away from this is that the operating system's security function is the thing that basically, when you turn a machine on and you have to type in your password to use the computer, that's the operating system. When you are at Western and you sit down in a computer lab and it asks you for your net ID and your password, that's the operating system, the network operating system, verifying that you are who you say you are, because you have the credentials, the password that matches up with that particular ID. That's the operating system in action. It can also include stuff like biometric scanners, or if you've got a laptop or a phone with a fingerprint reader on it. If you have a camera, and I think I've read several articles where Windows 10 that's coming out basically has a biometric feature that can be tied into a webcam. So instead of having to type in a password or scan your finger, you can just basically look at the webcam and it's going to recognize you through your facial geometry. Those sorts of things are security mechanisms in place. Now on top of that, you can also do things like password protect folders, password protect drives, encrypt things. All of that sort of encryption and that sort of work is going on through your operating system through its security features. So it's a very important portion of a very important function of the operating system, and those guys all together, it's a lot, and that's why modern computers require really good processors and a lot of RAM, is because on top of doing all of this stuff, this is just the operating system. On top of doing all of this in the background, then you have to have enough memory and processor to do all the other fun stuff like play games or open up spreadsheets or open up browsers or do all the application software kind of stuff that we would want to do. So those are the functions of the operating system, and I want to make sure you're well aware of those. Okay, to finish up basically the discussion of what operating systems or system softwares do, to identifying what their jobs are, there are a couple more tasks that are identified as some things that the system software will perform. In this case, it's talking about operating systems specifically. If you're looking in the book, you're around like pages 182, 83, 84, 85, and it's talking about various techniques that the operating system can make the machine work faster or use the existing hardware and make it work better or more efficiently. It talks about multitasking and multi-threading, multiprocessing, and parallel processing. These are processor CPU jobs, and basically it's ways that the computer can take that piece of hardware and work more efficiently. And so what I want you to take away from this is you look at the graphic here on the screen. You have multitasking and multi-threading up here, and it talks about a single CPU, and then down here it talks about multiprocessing and parallel processing, and in this case it's talking about 2 or more processors. If you've bought a computer anytime recently, you're going to be talking about something down here. I mean, I can't think of any computers you'd buy nowadays that would just have like a single core in its processor. Now, if you're talking about a phone, okay, phones, because phones are still a lot simpler than like desktops and laptop computers. Okay, yeah, then we can still be talking about multitasking and multi-threading, because we're talking about a single processor, a single CPU, versus down here we're talking about multiples. But in all the cases, essentially what's happening is the computer or the operating system is looking at the jobs that have to be completed and then completing those as efficiently as possible. With multiprocessing, what it does, it takes the available cores, like I showed you through that task manager a second ago. I had like cores 0 through 7, right? Well, each one of those cores was assigned something to do. In this case, core 1 or CPU 1 was told to do this, and this for word processing, and core number 2 or CPU 2 was told to do web page and email and finish loading the web page. And so in my case, the one I showed you, there were 8 different CPUs or cores in which to divide those tasks out among, and you can see how it kept the workload pretty easy for each one of those. There was like one, like CPU or core number 1, that was kind of working a little bit harder than everybody else, but the other 7 were kind of chilling. That's multiprocessing. That's what you're going to see in your desktop and your laptop computers. Parallel processing is when you actually have multiple chips in there, and this is like when you're talking about like supercomputers and mainframes and stuff like that. So when you actually get into parallel processing, it can take all those existing chips, and then it's still going to do one thing at a time, but it's going to divide the work out among all the different processors, and then, so it's going to get them done really quickly it's just going to spread the work out, and everybody's going to do like a little chunk of the big job. And so what do you need to take away from this? Well, basically you need to take away that these are just different techniques that operating systems can use to make the hardware work as efficiently as possible. And any kind of modern computer you're going to get is going to have multiple cores within the processor, so you're probably talking about multiprocessing as its technique. If you're talking about a phone, okay, we can still be looking at like multitasking or multi-threading. So if you have questions about that, let me know. But that's one of the topics talked about in this chapter. Okay, let's move on to our last couple of things to talk about it as far as like how operating systems or how system software works. It manages memory, and the operating system or the system software is going to take the available physical RAM or physical memory and manage what data is stored in that RAM. When it runs out of space in physical memory in RAM, it's going to then go to the hard drive and use something called virtual memory. And I show this to you just because you have seen you've seen the components of a computer, and through that whole Chapter 2 and Chapter 3 lesson, you're learning about the components, and Chapter 4 like all the physical layout of the machine. So let me show you some pictures here. This is a motherboard, and you've seen this before. We've got a processor here, right? This is where the processor would be, and then this dude right here is where the RAM would go. So I'm going to put RAM in there. So there's some RAM, and as much as possible, the processor is going to want to store stuff directly in RAM because it's right next to it and it's really fast, right? And you learned all about that back in chapters 2 and 3. And eventually, if you ask your computer to do a whole lot, like you have like 6, 7, 8, 9, 10 different applications open, at some point you're going to run out of space in RAM. And so what does the computer do next? Well, what it's going to do next is it's going to use the hard drive like it's RAM, and this is virtual memory. That's what that's called. And so I want you to see how that physically works. And so instead of being able to store stuff right there really quickly, it's going to have to go through this long cable out to the hard drive, and there's a certain portion of the hard drive called the swap file or the page file. It's either term is they're synonymous. So page file or swap file on the hard drive, which is used like RAM, and it's much further away. I mean, you've got this whole long cable here, and this is an old platter-based IDE hard drive, but even if you're using a SATA drive, which does not have the moving platters, but it's there's still a cable in place here, even with the SATA drive, that this is just much further away than like the 2 inches you've got between the processor and the RAM. And so anything that's going to virtual memory is going to be slower, and that process of using virtual memory a lot is called thrashing. And so if you have a machine that's older and you're trying to do a whole lot with it and it's just not performing well and it's constantly going to your page file or your swap file, that condition is called thrashing. And so the operating system manages that. You can get into the operating system and actually allocate how much space on your, I'm trying to get my mouse where I can see it. You can allocate how much space on your hard drive is going to be treated as a swap file or page file. The other reason I bring this up is because later on, if we talk about computer forensics, when the police go and they seize a computer and they're trying to get evidence from it, one of the best places to find really damning evidence on a bad guy's computer is in the page file, because he's thinking, hey, I'm just using RAM. Whatever I have open is just existing in RAM here. And he doesn't realize that because he has a bunch of stuff open, that his computer's actually storing stuff on the hard drive. So incriminating passwords, incriminating photos, documents, all sorts of stuff can be stored in chunks and pieces in this swap file out here on the hard drive that can really help investigators. And so I bring that up now as well, so because we might refer back to that again later. But that page file, swap file, all that stuff is managed by your operating system. The last job, or the last, how does it work kind of thing is this discussion of buffering or spooling. And This is supposed to be a spool of thread. Like if your mom or grandma, you've ever seen your mom or grandma, knitting or sewing, you've probably seen like spools of thread or yarn. And your computer, when it sends jobs to, especially to print, it's going to spool those. And what that means is basically the RAM or the memory within printing devices especially is really small. It may only be able to handle like a page at a time. And so let's say you send like a really pretty brochure that you've gotten for WKU's ATP or WKU's some event that's coming up and has like a lot of colors and huge pictures and really pretty graphics and all that kind of stuff. When you send that to print that, the printer's going to like go, whoa, wait a minute, I can take like half a page or one page at a time. And so what the operating system has to do, because the operating system is the device that's actually interacting directly with that printer, it's going to take and pass data over there chunk by chunk by chunk and hold the rest of it on the spool. It's going to wrap, think about all the thread wound up on this spool right here. And so that buffer, that spool, that queue, those are all different terms that are kind of synonymous. And that's something that your operating system does. Okay, so we've covered really like the hard part of this chapter. The rest of it I think is pretty easy, and we go through it really quickly. At least my portion of it to talk to you about it. The next section of the book, it talks about different categories of operating system, and it talks about additional categories, but the one I really want you to pay attention to is basically we have like personal versus server operating systems, and we also have mobile operating systems and embedded operating systems. And if you can differentiate between these these four, personal, server, mobile, and embedded, then I think you're in good shape. The personal operating systems are basically ones that you'd use on a personal computer like a laptop or desktop. A server operating system is something that people that are information technology professionals that manage like big networks, those are things that they have to worry about. So for example, let's say you're in charge of all the computer labs and mass media, and you want to be sure that people log in with their net ID and password, and that matches up with the correct information and banner, and that only that students get access to this pieces, these pieces of software, where faculty get access to these other pieces of software. That level of complexity, that's network operating system stuff. And so if you went and bought that sort of stuff, you'd see like Windows Server 2003, Windows Server 2008, or whatever the versions are. And as a normal human, just user of computers, we don't have to mess with that. We're just concerned with personal operating systems, things like Windows 8.1 or Windows 7 or Mac OS 10 or the Linux operating system, and those are complicated enough. But if you get into like network management, then you're going to start messing with these server operating systems, and examples would include like the Windows Server line of software. Now, mobile devices and embedded operating systems, those are things that go into things like phones and tablets, and embedded operating systems will be things like operating systems built for specific pieces of equipment, like a Keurig coffee maker. And I think I've alluded to that in a previous, like all the way back in chapter 1. Like embedded computers, like that run the anti-lock brake system of your car. They've got their own little embedded operating system that run them. So 4 different categories that I want you to be concerned about. Now, let's just take a look at a couple of screenshots of what some of these look like. DOS and Windows, they're all kind of part of the same thing. If you have a Windows computer, you can get to that DOS prompt, and you've seen that before when I showed you the command line interface. And so that's the Windows operating system and what it would look like. You have the Mac operating systems, the OS 10, and there are different versions of it. You have like the ones named after like different kinds of lions, like mountain lion and leopard and so on and so forth. And then like there's Mavericks, and there's another one that's out now. But there, you have the Mac operating systems. Now this is Linux. This is a screenshot of Ubuntu, which is just one version of Linux. The different versions are frequently called flavors, and so this is one flavor of Linux. And this is the one that was created by that Linus Torvalds guy that I mentioned to you earlier in the lesson, that the college kid that basically put the kernel of the Linux operating system out on a web page and then let other people contribute to it. As far as mobile systems, your phones and tablets and things like that, man, there are a ton of operating systems available for those. And you've got everything from BlackBerry to the Windows versions of them, to the iOS operating system for like your Apple devices. You have the Android operating system for your Android devices, your Google devices. And so here are some questions that I would encourage you to think about. And what I'd like for you to do is go ahead and pause the video for a second and read those questions, please. Okay, and I've mentioned several of different examples already of different operating systems for mobile devices, but I'd like for you to be able to identify some benefits and drawbacks of there being multiple operating systems. Just to give you kind of a head start, I mean, like, it's pretty in a in a capitalistic society. You want that competition, right? Because if there's competition, then there's going to be some motivation for providers to provide things to you at a cheaper rate. So if there's just one provider, he can charge you whatever he wants if you want to use that kind of device. But if we've got like 4 different, 5 different, 6 different sorts of platforms out there, they can make stuff cheaper to attract customers, which means lower bills for you and me. That's like a benefit. If we're talking about a drawback, if you go from the iOS system to an Android system, can you take all of your data and all of your stuff and just easily go from one phone to another phone without any problems? Well, the answer is probably no. So there are drawbacks too. So I want you to be thinking about benefits and drawbacks of there being multiple operating systems available for those mobile devices. Okay, and to close this lesson, I just wanted to briefly mention utility programs to you. Utilities are pieces of system software that do a specific thing. And what makes it kind of hard to tell a difference between like an operating system and a utility or a device driver is that operating systems include utilities. Operating systems include device drivers, but I'm going to show you 3 different utilities that I really like. They're like 3 of my favorites that I have on this computer. And what I just want you to take away is that this is system software. It interacts directly with the hardware, and it's something that basically it's got a limited use. You can't take a utility and have it go and like, for example, I'm going to show you the CCleaner program. You can't have CCleaner, which is used to like clean out temp files and stuff you don't need, and go and have it scan the drives for problems. I mean, it can't do that because its only job is to like clean out these temp files, right? And so, but it does that cleaning out of those those temp files really well. And so, as you're trying to identify utility programs, they do a specific thing super well, and that's kind of their niche. And so I want to show you 3. I've got one called CCleaner I want to show you. I've got another one called Malwarebytes that I want to show you. And I've got another one which is called View, which is probably really a better application program, example of an application program than a utility, but I want to show it to you anyway because it's free and it's a really cool program. So I'm going to show you these 3 right here: CCleaner, Malwarebytes, and View. Okay, this is the first one. This is CCleaner, and it comes from a company called Pyroform. And I'm going to open up the Pyroform website here. I learned about this from Mr. Willis, who's one of our. He's basically like the network administrator for our department. He maintains all of our equipment, and he knows how to build computers. He knows how to maintain them. He can build networks, all kinds of. He's super skilled. Network-wise and hardware-wise, and so we were talking about ways to optimize or best make your computer work. He recommended this CCleaner program to me one day. I'd go like, dude, that's great. And so from the download page, you can get like CCleaner, and there's like the different versions. This free one is the one I use. But what it does, I'm going to go ahead and close the window out right there. What CCleaner does, it looks at your computer and it can do a number of things. It can basically clean out files you don't need. It can work on your registry. It can help you uninstall things, and you can go into options here and you can control how it's going to work. But just the cleaner part alone, if you click on basically analyze, it'll tell you how much space it can free up for you. To actually make it work, you click on the run cleaner, and it will get rid of and I have it do pretty much everything. When you first install it, you'll see like all this stuff checked down here. That's not checked when you first get it. A lot of this stuff isn't checked, but I have it clean out stuff all the time. If you've got an old computer that's just not running as quickly as you would like for it to, download this thing from Pyroform and just run the cleaner, just a default clean of it, and I bet you're going to see a performance increase. This thing is awesome. And all you got to do is click run the cleaner, and I'm not going to do it because it's going to tax the system. And I'm recording right now, and this screen capture software is pretty taxing on a processor, so I'm not going to run this on top of that. But you just click on run the cleaner, and it will go through and get rid of all that junk for you. And it's just basically temp files and cookies and stuff like that you don't need anymore. And when it's done, your machine is probably going to be working faster than it was before. So really cool program. So that's CCleaner, and you can get that from pyroform.com. The next one I want to show you, you've probably heard of before. It's called Malwarebytes. It's anti-malware software. And what Malwarebytes does, it basically, I use this on top of Windows Defender. Windows Defender is my my malware or virus software, my antivirus software, and I use this one as a backup. And so I use the free version of it, and it doesn't run all the time. It only runs when I turn it on, and then I run a specific scan. But this program can catch stuff that Windows Defender misses, because it's created by a different manufacturer, and the signatures that it uses to find malware are just slightly different than what the way that the Windows Defender people do it. And so I love this as a backup to my main antivirus software or my anti-malware, which is also free. But Malwarebytes is free. Windows Defender is free. How do you get this? You can just do a search for Malwarebytes from Google, and you can download it. I've pulled up the web page for it. It's www.malwarebytes.org. Malwarebytes is B-Y-T-E-S. And you click on for home, Malwarebytes anti-malware, and then you can get the free download there and download the software. But it's a really good program. And again, I use this as a backup for my Windows Defender. Now, my last thing I wanted to show you, again, is probably not the best example of a utility, because it's probably more it's more of an application program than a utility. But I include it because I think of it as like an image utility. When you're working with images, it's called IrfanView, and it is completely free. You start it up, it looks like this, and you go like, well, what's that all about? There's really not much to that. It comes from irfanview.com. You can basically download it for free, and I'll show you what it can do here in just a second. Okay, here is the web page for IrfanView. It's IRFAN View. Irfan is the first name of the guy that basically wrote this software. It's been around for a long while. This is a Windows-based program, so if you have like Windows 98 through Windows 8.1, you can get this and use this, and there's a download link right there, and different places to download it from. But I like this because you can take big pictures, and you can very quickly resize those and change their file type. So let's say you have like a JPEG and you want to make it a PNG, or vice versa, or if you have a bitmap and you want to make it a JPEG or whatever. This is a really easy way to convert the format from one to another for free. You can take stuff that's in color and you can convert it to grayscale or black and white. You can take pictures and crop those really easily, and so it's and that's all it's used for. It's just used for image stuff. And so that's why I consider it a utility, although it's probably a good example of an application program. Let me pull up a picture and I'll show you how it works. Okay, I'm just going to open a file from my computer. I have some stock footage photos from this Vince Vaughn movie, Unfinished Business, and you can see that this is a pretty big photo. Down here in the dimensions of it, it's 1920 pixels by 1280, and so it's pretty big picture. And if I wanted to do something like, let's say I want to convert this from color to black and white, I can do that. I have that option through Image, Convert to Grayscale. It takes it and basically makes it black and white. I'll undo that because it is a nice color picture. Let's say I wanted to resize that to where it's really small, so because the smaller the picture is, the faster it emails, the faster it downloads. And when you're making websites, you typically want a smaller picture if you can get it. So I can go to like Image and Resize, and I get this really nice interface here. I can go like here and just half it, like it's at 1920 by 1280, hit half, and it's going to take it down to 960 by 640, hit OK. And the let's say I want to just crop where it's just Vince Vaughn's face and not the rest of it. I can take that selection of it and then go to Edit and Crop, and then it's just that. Like I'll get my the pictures I'll put is like my Blackboard photo picture, like or my, when you go to my info page, I'll use this to get it to the right size. Let's say I wanted to resize that specifically to like 150 pixels by so and so pixels. I can go here and say the biggest part's going to be 150 pixels. It automatically proportionally does the other. It's OK and does that for me. And then you can see it's a JPEG now. If I wanted to save that in some other format, I can go to Save As and then put that on my desktop. I'll call this Vince, and I'll make it into a PNG file. And you just select the format you want, hit save, and then I can close that out, and there's my PNG file of Vince. And so just one last example, that IrfanView is, I consider it an image utility, but I hope that this has been a helpful lesson for you. System software is something we have to have. We don't buy computers because we want system software. We buy computers because we want application software, but we have to have the system software in place in order for the computer to work. So thanks for your time and attention. I hope that it has made sense, and have a good day.